INCOIS in August 2020. He has more than 22 years of working experiences holding progressively senior techno-managerial positions at premier scientific organizations such as Intergovernmental Oceanographic Commission (IOC) of UNESCO, INCOIS.
This IISF event being hosted by INCOIS. INCOIS is the Indian National Center for Ocean Information Services under the Ministry of Earth Sciences, Government of India. With great pleasure and on behalf of all the organizers, I would like to welcome Dr. Sailesh Nayak, Director of the National Institute of Advanced Studies, former Secretary of the Ministry of Earth Sciences, and also very importantly, he was also the former Director of INCOIS. So he has agreed to be the chief guest for today's event and has kindly agreed to enlighten all of us and the students who are going to participate by giving a science talk on Earth Science for Self-Reliant India. I warmly welcome you, sir. I also warmly welcome everyone following the live broadcast of this science outreach event from far and wide, especially young students, academicians, researchers, general public, and media colleagues. Launched in 2015, IISF has inspired several people over a wide spectrum ranging from school children to researchers. This mega event is a huge platform to bring together various stakeholders such as students, researchers, innovators, artists, and the general public to celebrate India's achievements in S&T. The event is also a platform to envisage how science could lead India towards becoming a developed nation. So even the present pandemic couldn't hinder this agenda, and then we are all doing these events virtually. And during the curtain raiser ceremony, Honorable Union Minister of Science and Technology, Earth Sciences and Health and Family Welfare, Dr. Harshvardhan, also announced for several outreach events to popularize this mega event. Now, as part of the promotional activities for IISF 2020, Vigyan YATRA is being organized during 30th November to 21st December, starting from the northern, southern, eastern, and western parts of India to New Delhi. INCOIS is proud to host the Hyderabad milestone of the southern route, that is Dr. Kalam Yatra, in collaboration with Vibha, NGRI, NIAB, and ARCI. This year's theme of IISF is Science for Atmanirbhar Bharat, Self-Reliant India and Global Welfare, which is the vision of the Prime Minister for making India a self-reliant nation. And this initiative has created a boost in scientific activities in India, especially even during the COVID-19 pandemic, where we have witnessed a lot of indigenous innovations for healthcare. As most of you are aware, INCOIS is a Hyderabad-based institution, and it has a mission to provide ocean information and advisory services to society, industry, government, and scientific community through sustained ocean observations and constant improvements through systematic and focused research. The Science for Atmanirbhar Bharat also fits very well to what INCOIS does on a day-to-day basis. INCOIS was born in 1999, the same year that India launched its first ever ocean color sensing satellite, and since then has made giant strides in delivering its most popular societal application for fishermen called PFZ, which is very importantly, I would like to mention, is indigenous, world's largest, and self-reliant. Similarly, INCOIS is a shining example of India's leadership in Indian Ocean region when it comes to ocean observations, modeling, forecasting, and very importantly, tsunami and storm surge warnings, which is actually providing information to 25 countries in the Indian Ocean rim. So you will witness all this in the subsequent session during the INCOIS virtual tour. With these few words, I'm glad to accept this opportunity to host this event. I'm very confident that IISF in general and this event in particular will provide guidance and motivation for the younger generation in whose hands we will put the reins for the future. Stay safe and thank you very much.
Thank you so much, sir. Thank you for your insightful words. I now invite Dr. V.M. Tiwari, Director, National Geophysical Research Institute, for his welcome address. Dr. Tiwari's research interest primarily focused on deciphering subsurface mass distribution and mass transport relevant to a wide range of scientific and societal applications. Sir is a recipient of several national awards. I request Dr. B.M. Tiwari, sir, to address the gathering. Sir, please.
Thank you. Respected Professor Nayak, today's chief guest, the directors of the Ministry of Earth Sciences, Department of Science and Technology, Department of Biotechnology, representative of the CSAR, Professor Padmanabham, Dr. Mazumdar, Dr. Srinivas Kumar, our fellow colleague from ICT, Dr. Ramanuj Narayan, Dr. GLN Murthy Garu, and Bhanu Prakash Garu from NIN. This is really a rare occasion in the city when we have almost all the scientific departments together to have an event where we are trying to reach the common people, our scientists, young researchers, the future of our country, and also having very distinguished colleagues and the people who have made India proud over the years, like Dr. Nayak, right from his ISRO days to leading the uh, Ministry of Earth Sciences for several years. We all know that development is required in every individuals to every nation, and in all aspects, the developments to happen, the science and technologies go hand in hand. Today, countries are classified as developed and developing countries. The major categorization is based on economy and the application of science and technology. You are aware that many developmental and modernization models are now being challenged in the light of COVID, and that is the reason we are today having a mega event which is centered towards Atmanirbhar Bharat. No country has achieved self-reliance without mass quality public education and science and technological advancement. India has completely missed the third industrial revolution, which is marked by the development of the electronic goods, microprocessors, personal computers, mobile phones, etc. Today, India is world's second largest smartphone market. However, it does not make any of these phones itself. One can imagine the economic loss because of it. And therefore, again, I would emphasize how important this event is when we are talking of Atmanirbhar Bharat or self-reliant India. I would also like to say a few words on the importance of the earth sciences, in which domain our institute very extensively pursuing the research for last 60 years. Human society is built and sustains from the terrestrial resources drawn from the earth's outer layer in the form of the water, food, minerals, and fuels. Earth sciences is also a fundamental pursuit of understanding the natural world and exploration to learn about the origin, evolution, and future of our planetary home. And research on all these are being carried out at the institute where I come from, CSAR, National Geophysical Research Institute. We are very fortunate today that we have with us Dr. Nayak, who steered the Ministry of Earth Sciences, the central ministry which looks after the research and the application of the earth sciences for the benefit of the nation, and will be speaking on the several of the important benefits that country has received during past decades and future possibility of its application towards the Atmanirbharta. Thus, it's a very clear that self-reliance cannot be achieved without the interventions, without the progress in the science and technologies. And for this, researchers at the national institutions, universities, and PSU needs to be scaled up significantly, and outreach like Vigyan Yatra, for which we all are assembled today, is certainly going to make self-reliance initiative as a national movement by attracting young generation towards science. With this, I welcome all once again, all our panelists and the colleagues and the young researchers, students who have joined through us, though virtually, but on a very important day. Jai Hind and Namaskar.
Thank you, sir. Thank you so much for your inspiring words. Next, I invite Dr. Subir Mazumdar, Director, National Institute of Animal Biotechnology. Dr. Mazumdar has immensely contributed in the field of animal biotechnology, genomics, and animal reproduction. I request Dr. Subir Mazumdar to deliver his welcome address. Sir, over to you.
Good morning, Namaskar. My great respect for Professor Nayak, Padmanabham, Dr. Srinivasan, Dr. Tiwari, Ramanuji, and Murthy ji and other dignitaries. And हम लोग यहाँ basically इकट्ठे हुए हैं 22 से 25 दिसंबर को IISF 2020 we have to really celebrate in the form of a festival. That's the main message. And this festival of India is for young minds of students, mature minds of the teachers, and inquisitive minds of the common man, who are always looking for solutions or answers to questions to make themselves knowledgeable. So even common man has that enthusiasm. So they want to make themselves knowledgeable so that they can enhance clarity of mind. This means that students are needed to be motivated to have this bent of mind to serve society. And we teachers, scientists should help in dissemination of knowledge and ensure that benefits of the science reaches to everyone in the society. If you really understand Vigyan Bharati's motto, if you can sometimes go and see what is the aims and objectives of Vigyan Bharati, you will find that it's with the same frame of mind that those objectives are made. And you will find that this is made in addition to one important thing, that is self-reliance India with indigenous solutions to problems of the India. Then only we can look after our masses very dearly. Now you should be proud, and this is to influence young minds to do science, conduct science. And why should they conduct science? So our minister has really worked very hard, Harshvardhan ji, to really bring out India to a very top level. And he has got the statistics and kind of things which he disseminates nowadays. You will be happy to know that India ranks third among the most attractive investment destination for technology transaction in the world. Dr. Harshvardhan has really reiterated that technology is a strong priority area of government, and it aims to make people science-centric, everyone. Modern India has had a strong focus on science and technology, realizing that it is key element for economic growth. अगर science नहीं है, technology नहीं है, तो खुद हम स्वास्थ्य जिसे कि economy का स्वास्थ्य कहते हैं वो नहीं होगा. India is among the topmost countries in the world in the field of scientific research, positioned as one of the top 5 nations in the world for the space research. And in September 2020, India has moved 4 places up to reach to 48th rank and made the top 50 countries in the Global Innovation Index for the first time. Now, India ranks in top 15 for indicators such as information and communication technology, services exports, also graduates in science and engineering, and so many other R&D activities. Now, you can work in different sectors. Students, I am specifically saying, you can develop yourself into a scientist and work in several sectors such as agriculture. There are problems, healthcare, space research, nuclear power through your scientific research. For instance, India is gradually becoming self-reliant in nuclear technology. So we do not have to look, हमें दूसरों की तरफ देखना नहीं है. हम खुद ही बहुत अच्छे से आत्मनिर्भर हो गए हैं. India is aggressively working towards establishing itself as a leader in industrialization and technological development. India is doing very good in nanotechnology. Moreover, nanotechnology is expected to transform India's pharmaceutical industry heavily. We have very good scientists of nanotechnology. We can aspire to position India among world's top 5 scientific powers और उस सब के लिए हमको बहुत मेहनत करना होगा और इसके साथ साथ आत्मनिर्भरता भी बढ़ेगी जैसे जैसे हमारा ज्ञान बढ़ेगा. The coronavirus outbreak gave us massive boost and also fast tracked innovations. आप देखिए किस तरह से इंडिया में कितनी वैक्सीन एक साथ हम डेवलप करने की ताकत रखते हैं. जब मुसीबत आई, so we really worked very hard, and that means we have ability to do. We must always think that we are under pressure to bring India at the top. In the last 5 to 6 months, the industry, academia, and government came together to find solutions for unprecedented health-related issues of the country and this crisis which is faced by humanity today. We at National Institute of Animal Biotechnology work with a motto, Manav Kalyan ke liye Pashu Swasth. That means animal health for human welfare. I would think that science should work for animals as well as human, all living beings, also for the plant and also for the environment, so that everyone can successfully, healthily live in an environment. If you can stop diseases at the level of animals, human beings will not suffer, whether it is coronavirus, Nipah virus, brucellosis, so many diseases, mad cow disease, they all come to human beings. And if you stop them in animals, you can. So we work for that. And I would really tell that all of you who are listening, who are teachers and students specifically, you should learn and turning actually the ideas into the solutions. An idea can come in anybody's mind. Even a common rickshaw wala can give you an idea. If you are educated, pick up that idea and really try to find a solution for a problem. You need not be very studious. You should practice to be innovative. Innovative for finding ideas, to have solutions for farmers' issues, for doctors' issues, for pending issues in the engineering, so that we can have more by spending less, whether it is renewable energy or any kind of thing, or indigenous knee joints, indigenous catheters for the cardiology, so that it becomes very cheap and accessible to everybody. आत्मनिर्भरता और हर गरीब के पास हम पहुंच सके, जो अफोर्डेबल नहीं है उसे अफोर्डेबल करें, so that everything becomes easily available to general masses of our countrymen. इसी उम्मीद के साथ मैं वो जो सभी स्टूडेंट्स सुन रहे हैं उन्हें मैं आग्रह करूंगा कि साइंस लें और देश की सेवा की भावना से लें, और टीचर्स को आग्रह करूंगा कि जितना हो सके इस चीज को फैलाएं कि हम जितना साइंस सीखेंगे, जितना उन्नत होंगे, उतनी ही आत्मनिर्भरता आएगी. नॉलेज विल ब्रिंग द सेल्फ रिलायंस. विद दिस आई विल स्टॉप विद वेरी गुड विशेस फॉर ऑल ऑफ अस हु आर लिसनिंग हियर. थैंक यू वेरी मच. जय हिंद.
धन्यवाद सर, आपके प्रेरणादायक शब्दों के लिए बहुत बहुत धन्यवाद. Now we will end this series of welcome addresses with the welcome address from Dr. G. Padmanabham, Director, International Advanced Research Center for Powder Metrology and New Materials. Sir's able leadership led the Center for Laser Processing of Materials developed a range of applications for automotive power, aerospace, electronics, nuclear, and other sectors. I now request Dr. Padmanabham sir to address this event. Over to you, sir. Thank you.
Thank you for the nice introduction. Professor Shailesh Nayak, Dr. Srinivas Kumar, and the fellow directors of research laboratories in Hyderabad, senior scientists, teachers, students, and all other participants of this event. It's a wonderful opportunity to be able to share some thoughts in such a forum. In fact, more or less, it's not very often that labs, all types of labs like what we have gathered today, represent on the same platform and share information. In fact, as I talk today, I recall the experience of IISF events that we organized last year at ARCI. What we thought and planned for an exposure to young students by talking to schools and colleges, a participation of about 500 people, 500 students will come and visit our lab and physically see the demonstrations and the materials developments that are happening. We ended up with more than 2,000 students turning up for that event. It indicates a great uh, enthusiasm among students for knowing more about science that's happening in the country and also imbibing some of those ideas into their own interests that they want to pursue. It's a very encouraging sign. Coming to the importance of the areas of research that ARCI works on. First of all, ARCI is a laboratory of the Department of Science and Technology, about 25 years old. And we work on development of materials and manufacturing processes, which are used by several industrial sectors, starting from biomedical sector to aerospace to defense, automotive, oil and gas, and you name it. So as all of us know, the human civilization itself is identified by development of materials. If you recall, uh, it is the civilization is milestoned by Stone Age, Bronze Age, Iron Age, Age of Steel, Age of Polymers, Age of Silicon, and now Age of Molecular Engineering. So today, if you look at any industrial sector, 70% of the innovations that happen are based on availability or the capabilities of materials that we have and we can develop. So, keeping this as the background, we do materials research at ARCI with the idea of developing them and demonstrating them at an industrial scale and transfer them to the industry for commercialization. So, the the concept to commercialization is what is important and which is relevant in the Indian context when we talk of self-reliance. Many a time, the laboratory research doesn't reach the user finally because of several reasons. Uh, we measure the development of a technology in terms of what is called the technology readiness levels, TRL 1 to 9. And many of the technologies, especially when I talk of materials related technologies, they do not cross a TRL 6, which TRL 5 or TRL 6, which we call after that it is valley of death. So the valley of death is because many of the lab scale technologies are not able to be translated into usable, commercializable technologies. And that's where the whole concentration is required, the so-called user pull, the industry pull, the economic pull, all these factors also come into my picture. So uh, understanding this need, what we do is concentrate totally on application-oriented research by exactly identifying what is the need in the society, what is the need in the industry, and launch such programs and develop materials and transfer. For example, uh, about 20 years ago, the so-called nanomaterials and nanotechnology research has emerged. And we try to use the nanomaterials for applications as simple as water purification to use in the health and hygiene through antibacterial coatings to using the same nanostructured materials for making high temperature steels for nuclear applications. And today, we are trying to use the same capabilities in developing nanostructured electrode materials for energy storage devices like lithium-ion batteries. All of us heard of the great emphasis that the government is putting on electric mobility in order to deal with the pollution. And the lithium-ion battery or the energy storage device is a key to successful economic technologies for electric mobility. So nanomaterials play a great role in coming out with high performance, cheaper energy storage devices. Similarly, we have several requirements from our defense as well as the space departments and the atomic energy departments, where we import a lot of, still import a lot of components which are sophisticated. For example, some of you who would have read the news in the last year, the DRDO successfully announced the anti-satellite missile Shakti successfully going and hitting a satellite. The front of the satellite is nothing but a ceramic dome which is transparent to the infrared rays, which helps in the guiding of the missile to the right target. And that ceramic dome is developed at ARCI. So why I mentioned this application is the range of applications or the needs of the society that we can meet by appropriate materials research is virtually every field, every need requires good materials development. And this is what we are aiming at and trying to do at the RCI. And we are welcoming scientists from all fields, all levels, and all organizations to interact with us and also visit us and join us in the mission of making this country self-reliant. Thank you very much. Thank you.
Prerna, you are muted. Please unmute yourself, Prerna.
Okay, sorry. I'm sorry. Thank you, sir. Thank you so much for your insight. I appreciate you to take time to share these very useful resources with us. The challenge of hosting this year's ISF in Hyderabad has been undertaken by Vibha, MOES, and CSIR, and everyone in this family is on mission to make this program a grand success. I now invite Dr. Vanu Prakash Reddy, scientist, Indian IMCR, National Institute of Nutrition, Hyderabad, and also a president of Vibha, Telangana, to deliver his presidential address. Sir has contributed immensely in the research focused on molecular nutrition of age-related diseases. Sir has numerous publications under his name and is a proud recipient of various prestigious awards. Sir, kindly address this gathering. Over to you, sir.
Thank you, Prerna. Good morning. सबको सादर प्रणाम. Dr. Srinivas Kumar, Director INCOIS, who took the lead and initiative of organizing this program called Vigyan YATRA, which is a prelude to India International Science Festival that is going to take place between December 22nd and 25th. Dr. VM Tiwari, Director NGRI, Dr. Padmanabham, Director ARCI, Dr. Mazumdar, Director NAIB, and special thanks to Dr. Shailesh Naik, Director, National Institute of Advanced Studies, Bangalore, who could spare time for this particular important activity. I represent or on behalf of Vibha, that is Vigyan Bharati, welcome you all and thank you all for joining this program. And it is such an auspicious occasion. I mean, let me say, what more auspicious can be than this, that all the heads of good number of national laboratories joined on a common platform to talk about science and how to go forward about it. And I think the credit goes to Dr. Srinivas Kumar for bringing all of them onto a common platform like this. I am here to say a few words about Vigyan Bharati. Vigyan Bharati is a voluntary national building science movement. More than an organization, it is a nation-building science movement based on the nationalistic ethos, which is established in the year 1991 by Professor K.I. Vasu at the Indian Institute of Science, Bangalore. Its objectives are to build modern India with the help of state of modern science, and also to rejuvenate and provide scientific evidence to traditional knowledge that is available in all walks of life or in all spheres of life. This is most important for us. Of course, modern science is done by all of us in a different labs, but rejuvenating and providing scientific evidence to traditional knowledge that is available in all parts of life is very important. As a dynamic science movement with a Swadeshi spirit, Vibha interlinks traditional and modern scientists on one hand. It also tries to bring in national and spiritual sciences together on the other hand for the benefit of the country or for the needs of the nation. The organization has its units almost in all states of the country as well as in many other countries. Eminent scientists and technocrats such as Dr. Late APJ Abdul Kalam, Dr. Anil Kakodkar, Dr. Madhavan Nair, Dr. V.K. Saraswat have guided and also have been guiding, many others have been guiding this movement, which is now functioning under the leadership of Padmanabham Dr. Vijay Bhatkar, who is an architect of first Indian supercomputer forum. The activities of Vigyan Bharati are spread to many spheres, such as organizing seminars, workshops like this, and also conducting brainstorms on various themes which promote science concepts to address the current problems of the nation. I don't want to list the problems that our philosophy is local solutions for the local problems. Think globally, act locally is everyone says, but we have to identify the local problems and find out the local solutions, because the global solution sometimes may not suit for the local problems. That is actually main concept. If I want to name a few, what are the things that we are facing? Conservation of energy and water, promotion of traditional science, particularly Ayurveda and many other traditional medicines, tribal welfare, so as to build self-sufficient modern nation. That is actually the theme of this year's IISF, that is self-reliant India, and also global welfare. As our philosophy, we don't just want to limit ourselves, the welfare to ourselves, because we think our philosophy is Vasudhaiva Kutumbam. Therefore, not only self-reliant India, but global welfare. That is the most important aspect of this year's theme. So, India International Science Festival is actually a brainchild of Vigyan Bharati. Now it is owned, organized and conducted by all the government agencies such as DST, CSIR, DBT, DRDO, Earth Sciences, all the government scientific bodies. So my colleague, of course, Dr. Ramanujan will elaborate on IISF, but this is what I would like to say, that science, the main concept of this Vijnana Yatra or the IISF is to educate the masses, that includes school students, college students, technocrats, policy makers, and common masses, common people about the developments of the science, what India has contributed, what needs to be done, how to go forward. Is the actually, as Dr. Subir Mazumdar said, everyone should be aware of the scientific aspects of it and scientific temperament. Once you know the fruits of the science, you know how better to use it for your day-to-day life also. Many a times there is a common perception that science belongs to four walls of scientists. This is what we want to break. We want to make science for everyone, science for masses. In other words, people's science. This is the actually concept of the Vijnana Bharati and IISF. So with this, I once again welcome all of you to this program, and I thank the main speaker, Dr. Shailesh Naik, and once again, my thanks to Dr. Srinivas Kumar for making such a wonderful arrangements. Thank you very much.
Thank you, sir. Thank you so much for your inspiring word. I now take this opportunity to invite Dr. Pradeep Agarwal, scientist, Defense Research and Development Organization, DRDO, Hyderabad, and also the representative of IISF 2020 to address this gathering. Sir, please.
Thank you, Ms. Prerna. Actually, I would like to share some slides, but I am not able to share. Okay, no issue, I will just continue. Good morning, Dr. Shailesh Naik and directors of all the research lab in Hyderabad, senior scientists, technologists, and my Vibha colleagues and president and EC members and all the delegates. Good morning one and all. And मैं आप सभी का इस IISF 2020 की इस पड़ाव पर विज्ञान यात्रा पर सभी का स्वागत करता हूं। मैं बेसिकली यहाँ पे IISF के बारे में एक्सप्लेन करने के लिए प्रेजेंट हूँ। Indian International Science Festival launched in the 2015. It is an annual event which is promoted by its main purpose is to promote science and technology and to demonstrate how science could lead India towards a developed nation. The aim is to engage the public with science and celebrate the joy of science and show the way how science, technology, engineering, and mathematics will provide the solution to improve our life. The main purpose, main objective of the IISF is विज्ञान को, साइंस को जन जन का विज्ञान बनाना है। इसके जो बेनिफिट्स हैं कॉमन मैन तक पहुंचना है, then only India can become a developed country. Ministry of Sciences and Technology, Ministry of Earth Sciences, in association with the Vigyan Bharati Vibha, has created a unique platform of Indian International Science Festival, which tends to inspire their curiosity and make learning more rewarding. The IISF 2020, it is a 6th edition in the series of IISF. It is scheduled on 22nd to 25th December 2020 by virtual mode. The 22nd December is the birthday of great Indian mathematician Ramanuji, and 25th December is the birthday of our former Prime Minister and visionary leader, Sri Atal Bihari Vajpayee. The main theme of the IISF 2020 is Science for Self-Reliant India and Global Welfare. It is very relevant to the present context, and this IISF will fulfill our vision of our great Prime Minister, Mr. Narendra Modi ji, for the Atmanirbhar Bharat. And this IISF will provide an opportunity to demonstrate the strength and potential of Indian science and technology, not only to the people of India, but to the entire international community. Former Prime Minister, President Dr. APJ Abdul Kalam, in his vision document 2020, he expressed and emphasized the need to achieve self-reliance in strategic sectors in the context of national security. There is a great need to build indigenous science and technology capability to protect the sovereignty of the country. He mentioned, unless India stands up to the world, no one will respect us. In this world, fear has no place. Only strength respect the people. And here, now I'm going to see in this IISF 2020, 40 plus events are going to happen, and Vigyan Yatra is one of the major part of that one. Under this Vigyan Yatra, the major events will be Science for Mass, where main objective is to outreach the program to the Jan Jan Ka Vigyan. In this session, Vigyan Yatra, then Science and Technology, Media Conclave, Indian science films will be telecasted. Then Science for Students, in this session, there are a lot of sessions for the Young Scientist Conference, Student Science Village, and Science Education in India. And there is a special session for the North Indian Student Conclave also is there. In the session of inclusive development, there is an emphasis on the women scientist, and entrepreneur conclave is there, and national social and organization institutional meet also is conducted under that one. Under the session of science and humanity, they will be focused on the Indian ancient science, and there will be demo and films will be telecasted under this Indian ancient science, because India has produced a lot of sciences, but in history they are not known. To highlight our India, we can motivate through our ancient science only. So under this program, a lot of demos, expo will be there. And under the New Frontier sessions, there will be program for the New Bharat Nirman, New Age Technology, and there will be a face-to-face interaction with frontier in the science. There is a special session for the industry and MSME, and we know to make the India as a developed country, the MSME and startups have to play major roles. So to focus on this growth of MSME and startup, there is a special session where the interaction between the industry, academia, and MSME will take place. And in the national and international linkage, because we don't want this science should be put up to only for the India in the common man in the India. We want our Indian science to should reach at the international stage. So the scientists, Indian scientists, technologies, overall the country will have the conclave, will have the session for to meet the Indian academia, industry, and basically the young scientists and researchers. We know the 70% of Indian public, it depends upon the agriculture and farming. So in this IISF 2020, the focus is stress is given on the agriculture and rural development. There is a session which will cover the agrotechnology, agriculture scientist meet, and there is a traditional craft and artisan meet and expo. We know this environment is a major challenge, and to become the world leader, we have to play major role in the environment cleanness also. So under the sustainable development, the special session for biodiversity, clean air, energy, habitat, and hello, then water and wellness. Wellness conclave is also planned under this one. Then comes to the.
In view of time, sorry to disturb. Maybe we have another session, guest lecture. So maybe quickly.
IISF provides a platform to young students, scientists, and technocrats from across the India for exchange of knowledge and ideas. It emphasizes on the role of science for masses, science for society. By participating in this one can influence the quality and direction of the and will reap the personal and professional rewards. And by this one, I extend the invitation to one and all to join this one, to celebrate this festival. And finally, I will conclude with the Swami Vivekananda one quotation: "Arise, awake, and do not stop until the goal is reached." Jai Jawan, Jai Kisan, Jai Vigyan, Jai Hind.
धन्यवाद सर, हमारे साथ IISF की अंतर्दृष्टि और विवरण साझा करने के लिए आपका बहुत बहुत धन्यवाद. I feel privileged and humbled to introduce the chief guest of today's function, Dr. Shailesh Nayak, to the audience. Dr. Shailesh Nayak is currently Director, National Institute of Advanced Studies, and a distinguished scientist in the Ministry of Earth Sciences. He was the chair of ESSO and Secretary of the Government of India for Ministry of Earth Sciences between August 2008 to 15. He provided leadership for the programs related to science of climate change, weather sciences, polar sciences, geoscience, ocean science, etc. Dr. Nayak obtained PhD degree in geology from MS University of Baroda in 1980. He joined ISRO in 1978 as a scientist and subsequently elevated as the Director of Marine and Water Resources. Dr. Nayak was appointed as the Director of INCOIS Hyderabad in May 2006. He set up a state-of-the-art early warning system for tsunami in storm surge in the Indian Ocean. He was responsible for the conceptualization and development of marine GIS. He made outstanding contribution in improving advisory services related to potential fishing zone, ocean state forecast, and Indian Argo project. Dr. Nayak is the chair of numerous research advisory committees of our country. Sir is also a fellow member of many prestigious national and international societies. He has been awarded honorary degree of Doctor of Science by Andhra University, Assam University, and MIT University. Sir is also a very proud recipient of many prestigious awards. To name few, he is a recipient of IJO Hari Narayan Lifetime Achievement Award of Geosciences. Sir, we are so much honored here today that you could join with us and eager to hear your address. Before I hand it over to Sir, one important announcement for the audiences. You may send in your questions at any time during the presentation in our YouTube chat box. We will collect this and Sir will address these during the question and answer session at the end of his presentation. May I now request Dr. Shailesh Nayak sir to deliver his talk. Over to you, sir.
Thank you very much, Prerna, and my distinguished colleagues, Dr. Srinivas, Dr. Tiwari, Dr. Padmanabham, Dr. Mazumdar, and the President of Vibha, Dr. Reddy, Dr. Ramanuj, representative of ISF, and all the colleagues who have been listening to this. I'm extremely grateful to the organizer for inviting me to deliver a talk on a very important topic on the self-reliant India and global welfare. As you know that the earth science is one of the important branch of science, and it is of a national importance because it directly links the science to the society. And in India, I would like to show some of the examples how this has been done. And I would like to acknowledge many laboratories under Ministry of Earth Science and the laboratories under Council of Scientific and Industrial Research who have been contributed to this science. My talk is based on the work which is done by them, not necessarily by me, but I will not be able to acknowledge each and because there are a large number of institutes, large number of people who have contributed to this. So at the beginning of the talk, I would like to acknowledge all of them for this wonderful work which they have done. Can I have a next slide? Yeah, the most important part of the Earth system science is that it's a global science. We try to learn what the mass and energy exchanges between the different components, like between atmosphere and ocean, the cryosphere, the biosphere, the geosphere, and this changes which are occurring actually shapes all the Earth system processes, including weather and climate or any other process. It may have that the different processes have a different spatial and temporal frequencies, but essentially the understanding of different changes, like if I give an example of a monsoon, the water evaporates from the ocean and the clouds are formed, the clouds are moved towards the land, the rain comes, and that rain again comes into different rivers and again go back to the ocean. So this is a kind of a system, and this kind of many such exchanges are occurring in the earth. And we try to understand these processes and try to provide the various products and services for the benefit of the mankind. Next. Why we have to do, there is always a debate goes on that what is important, basic science or applied science. In earth science, we don't distinguish this kind of differences. What we think is that there are three aspects, and our agenda we have set up is like this, that we need to find some of the science questions, we need to pursue the science questions, we need to try to understand new phenomena, we explore the different terrains, right from the heights of the mountains to the depths of the ocean. So the one which is very important part is the discovery. The second is understanding a variety of interaction which is taking place between the Earth system processes as well as how the Earth system processes interact with the human activities. So this we are trying to understand and try to model them. And the last is the knowledge which we have gained either through discovery or through modeling. We try to use this information for the public good. So my examples would be some of these where we have done all these three ultimately for the public good. Next. Next. The most important thing which is we are worried about today's world is the hazards. May I have a next slide? And I will give you a couple of examples on the, as you know, the cyclone. We have experienced cyclone a few weeks back, and it is coming. That was the fifth cyclone in this year, which we have witnessed. And we have seen that 20 years back or so, in 99, when Orissa cyclone came, is almost 10,000 people died. And today, with the using the various information and science and the observation, we have been able to reduce the loss of life practically nil. Now, how this happened? Now, this is one thing which is very important is that the observation from the satellite, our INSAT, the scatterometer and many other satellites, all this information is now assimilated into a models, and these models are now able to provide a track, landfall, what time it will come. All this information is now we are able to provide almost 5 days before. Now, because of that, the state government and the national government, including the local government, are ready to respond to this activity. So this is also very important. And we have seen that how the government have responded in all the previous cases. And but last to the most is the consciousness of the people. The people have now trust in this forecast and the government actions, and they are ready to move. They are ready to be evacuated, and the necessary facility for the relief is also being provided. So all these three components are very important, and that is why we have been able to reduce this loss of lives at a minimum. And not only to India, we are providing this information to all countries in Bay of Bengal and Arabian Sea. So the information which we are now able to generate is not used for India alone, but all our neighboring states. Next. And this has been recognized at the highest level. The Prime Minister earlier, Dr. Manmohan Singh, and the present Prime Minister Narendra Modi ji have recognized that how best this information has been used. And if you see the Pelin cyclone, which was super cyclone, the interesting thing is the use of technology specifies, and then the important thing he says is the velocity, the direction, the time, all remain same. And that is how this could be used very well. Next. The second, which Srinivas also mentioned, is the tsunami. In 2004, when we had a tsunami, most people were not even aware what tsunami is, except few geoscientists who would knowing what tsunami, but nobody has ever thought that India can be affected by the tsunami. Though in the past, 1945, we were affected by tsunami, but somehow it is not in the memory of our people. And the warning system which India developed, and that time, it was a major challenge. It was really built from the scratch. And the challenge was that the time which we get is about 2.5 hours from if it occurs in near Andaman Nicobar, or the other is the Makran coast. So our forecast has to come within minutes. Now, the challenge is that you need information from throughout the globe, because the first is you have to find the earthquake, where it occurred, what is its magnitude. So you need data on seismicity, then what changes have occurred on the sea level, so and the tides. So this information also you need from throughout the globe, and this we have accomplished using the satellites, our own satellites as well as the other satellites. And this information comes to a central point like INCOIS. I'm sure you would be shown this, and then we generate the forecast and provide it to all countries in the Indian Ocean. Now, the interesting thing is, at that time, the system which was available was the Pacific Tsunami Warning System by US and by the Japan Meteorological Agency. We have chosen something very innovative idea, and that was not even used earlier. Next. So what we tried to do is, we had divided entire area into a seismic 50 by 100 kilometer grids, and we estimated what kind of earthquake could occur in each of that and what kind of tsunami can be generated. Now, the Pacific Tsunami Warning and JMA were giving the basin-wide warning, and we thought that this would not be a useful thing. So we are giving forecast at 1800 points all along the Indian Ocean boundaries. So this was another new innovative thing was done. And then this system, since we have very short time, was completely automated. That means right from the collection of data to the reaching the first advisory to the all stakeholders, there was no human intervention. And this was the one major innovation was done at that time, because nobody was able doing that kind of thing. So this was a very, very challenging task, accomplished only in 18 months. We did far ahead between Germany and US, which were setting up in Indonesia and the other places. And even today, this system is considered one of the best, and we are providing to the entire community this. And all this process we are completing within 6 to 8 minutes. So this is a really remarkable achievement, completely self-reliant, and not only the government agencies, about 300 scientists worked on it, but also the private industry, TCS, also provided extremely good support for the software development. So this was really true, a self-reliant, and this is considered today one of the best in the world that which India has produced. Next. And this was also recognized, next, by Prime Minister. And you can see that the important world-class tsunami warning system, which Dr. Manmohan Singh mentioned, and Sri Narendra Modi ji mentioned about its importance on the regional, that the entire this region has been providing this. Next. The third, which is a very major hazard, which is of the earthquake, which is we have not been able to provide any input as of now. And we have also, apart from the natural earthquakes, there is a major thing which is now going on is a triggered earthquakes. Now this triggered earthquakes is something which is happening because of our own activities, like the impounding of the reservoir, or if you have a underground mining or oil so this kind of thing is also able to generate an earthquake if there is already stress existing in that particular region. And there are many such examples happening. Those who maybe the one, of course, is the Koina, which happened in the 67. But there are smaller earthquakes happening many places where even the heavy monsoon also is able to generate the earthquake. Of course, these earthquakes are not very large, but it do generate some kind of a panic in the people. Now, the major thing which if we want to forecast anything, the first thing is required that we need to observe them, like in case of a cyclone or a tsunami, and those observations we should be able to make. Now, in case of earthquake, we are not able to see what exactly happens in the depth of the surface. So the best thing is that whether we can go there and measure and understand what exactly is happening. Now, fortunately, next, in Koina, the earthquakes are occurring about 4 to 7 kilometer depth. So we decided to put a borehole and go right up to that and put various instruments to measure what kind of physical chemical changes are going on and whether there are any signs which we can pick up before the earthquakes are occurring. So this project has been now taken up. What you can see, the first borehole, the pilot borehole up to 3 kilometer has been drilled with completely Indian technology and the drilling. And this, the first time such a deep borehole has been put. Now the instruments have been put in these boreholes. Apart from this, there are many other small boreholes about 1 to 1.5 kilometers. I can't go into the details, but the analysis is being done. And based on this, we would be going up, which is shown in the next figure, right-hand side, up to 7 kilometers, and we will measure this. This is a very long-term project. It may take about 15 years for us to understand everything, but this is one which is a very major project, and this kind of thing which is happening only in India. USA did try such kind of a borehole, but the earthquakes are not occurring nearby to the measure. While we have been able to find that earthquake, even while drilling, we found the earthquake occurred there. So this is one of the very major project India has taken, and I'm sure that a lot of new knowledge will be coming out, which will be useful for the global people. Next. Some of the important thing which we have learned now that based on our current thinking that there is no possibility of a large earthquake happening in the Koina. This is very important thing. Apart from that, we knew that how much lava came out, total thickness of lava was not known. So this has been found, and many new things have been coming up. Those who are interested can, of course, talk to Dr. Tiwari or Dr. Sukhanto, who has been participating in this. Next. Next. Now, the weather is one of the most important. It affects everybody's life. And India today has one of the best weather forecasting system. And many of you might have noticed that we have improved our forecast significantly about what is likely to happen about rain, temperature, other extreme events, dust storms, thunderstorms, many other things. And this has been possible because of using the satellite data, our INSAT satellite, as well as the many other satellites throughout the world. And these again assimilated into a model, and we are giving from a short term to the seasonal forecast. Next. One of the major applications, there are several, there are 30 major applications of the forecast, but the one which is affects maximum is about the farmer. And the agrometeorological advisories have been provided to the farmer. Today, 40 million farmers are getting this message on their mobile in the language in which they would like to have. So this is one which is a very, very important thing. And this is going on for last 10 years or so. And tremendous benefit has come. The National Council of Applied Economic Research has just released the report. And they say the annual benefit coming is a 10,000 crore, which is much more than what government has invested in Ministry of Earth Science totally is about 2,000 crore per year. But the benefit from only one application is more than 10,000 crore. So there are several such applications for aviation. There are applications for floods. There are applications for power sector and many others. So all of them are benefiting tremendously by a very accurate weather forecast. Next. Now this kind of a system which was developed, and this was seen President Obama that 2009 when he came, he was very much impressed. And he talked to many farmers and he said that this is something which is very unique kind of thing. And he said that the India is a leader in using the technology to empower the farmers. And because of this, we entered into a major collaboration with US, where we have been collaborating to develop the model and to improve over the monsoon. And based on that, we have now been able to provide a major mission which was launched at that time on the monsoon mission. And we don't get into the lot of other issues, but the important aspect was that the accuracy was 0.4 and the maximum what you can get about 0.65, and we have already reached 0.63. So we invested very heavily into computing. We made a supercomputer, high performance computer, which was now about 7 to 8 petaflops. Also, we built collaborations along with US, UK, Japan, Australia, and many others. And we also set up a training school to build up the human resources. So all the three together has now put India into the forefront of the weather forecast throughout the world. Next. Also, we try to look at how the monsoon originated. So one of the major experiments conducted in 2015, where we drilled in the ocean along with US about 1.2 kilometers. And the rocks which came out, from which is a very detailed analysis, and we found that the current monsoon happened around 2.8 million years ago. And that was the time which there was a lot of carbon dioxide in this, and it was very warm. So the monsoon actually started along with the rise of the Himalayas. As Himalayas rise, the monsoon became stronger, and the current monsoon strength come about 1 million years ago. So we are trying to understand the monsoon right from how it is originated, what is happening, and also what is likely to happen in the future. Next. So this is our forecast is now next 100 years, how the monsoon is likely to behave is being done at IIT. And they are now participating in the IPCC consultations, where India is using its own Earth system model to provide the input. And this model suggests that there will be a decrease in the light rain and increase in the heavy rains. But the general total precipitation as of now not likely to change overall, but there would be some regional differences. The entire major report has just now been released. Those who are interested can see on the Springer has published the book on this, and very detailed forecast is being given. Next. Next. Similarly, on the ocean side, there are many services. Srinivas mentioned about the potential fishing zone. This is one of the farmers. About 4 million farmers, fishermen are today engaged in the fishing activities. And the major problem with fishermen was that when they go out, they were not knowing where to go, and they were trying to use their own basic knowledge. But unfortunately, they cannot see beyond a certain limit. So they were not able to identify areas where the fish is likely to be available. So using the satellite data, which was launched in 99, OceanSat-1, and now we are using also other satellites, the method was developed where the fish would be available. And a very simple concept was used, that basically the temperature of the seawater was considered as an index of the environment, and the chlorophyll is considered index of the food availability. And both where these match, we will give this as an area where the forecast is likely to be available. And this has been tremendously successful system. The fishermen are extremely happy today. About 95% of fishermen uses this forecast. It is been sent by variety of communication systems which we have, and their income has increased about 2 to 4 times. Actually, the National Council of Applied Economic Research, they have said that they save up to 17,000 rupees per trip. So this is just a saving in the fuel, but if you see the environmental cost, they are just putting that much carbon dioxide less in the atmosphere. So this is also very unique uh, system which India has developed, and today India is considered the leading as far as using the satellite images for the fishery forecast. Next. Similarly, the sea state, that means how the waves are there, how the tides, how the currents are moving. So this also has been a very detailed work has been done, and the extremely good models have been developed by integrating the different available models, and we have been giving forecast for wave currents for the different next. I will show you one small example. Next. So we are providing this kind of information on currents and waves and the mixed layer depth, sea surface temperature on the entire globe. We are providing for Indian Ocean. We are providing separately for Bay of Bengal and Arabian Sea, as well as the various ports. Actually, the forecast is also given for a variety of things, about 200 ports on tides. So right from local to global level forecasts are being provided, and India is the only country which also provides the forecast and its validation, what the forecast given and what was the actually happened. So this is another very unique service which is being provided, and this is also used by all seagoing people, including fishermen, our naval ships, the customs, coastal guards, as well as the other shipping industry. So this is another major thing which is being done. Next. Coral reef, many of you must be knowing that it's very important from the climate change point of view, and what is happening to the coral reef is very actively monitored by a variety of institutes, especially National Center for Coastal Research, along NIO and many others. And INCOIS provides a coral reef alert that wherever the temperature increase and the likely area which may get bleached is also provided now. Next. In our country, we have a called Coastal Regulation Zone, CRZ, and this says that from a high tide line to 500 meter, there are certain restrictions on the various activities. And this entire thing is now provided based on satellite data, where the high tide line and what is like the other features all have been provided to prepare the coastal zone management plan. India is one of the very few countries in the world where for the entire country, the coastal zone management plans are available today. So these are all available in a digital form on a website, and anybody can see that what kind of zones are available in the coastal area, what kind of activity is allowed or not allowed or restricted or regulated. So this is another major contribution from the earth science community to the country. Next. Similarly, the lot of erosion, and this thing is happening now for a variety of reasons because of the sea level rise, constructing various structures, and the changes which are occurring in our coastline is continuously monitored, and the likely possibility that why such things are happening is also being tried to understand, and necessary changes which could be seen, measured, and mapped, and then they try to understand, and probably in future we would be able to model as well. Next. The one which is very recently started is the blue flag beaches. So it has been ensured to ensure that the quality of water, safety, and this is certification and already 8 beach has been certified as a blue flag beaches. The blue flag word comes from there is a European NGO who agrees that this beach is good enough. So we have planned to make 100 beaches of a blue flag beaches. The first 8 beaches now considered as of international standards where all the facilities, everything is available. Next. Similarly, the coast is also vulnerable to cyclone, tsunami. So we need to find out how much area is likely to be inundated and which are the areas. Actually, cadastre also is superimposed over it to find out that which area is likely to be affected by which kind of an hazard. So this kind of risk assessment maps for the entire country is also available. Next. Next. The other is, of course, the lot of minerals and water is now scarcity. In Lakshadweep Islands, the water is not available because it's a coral island and the water is very shallow and it gets contaminated by the various wastewater and all. So the one which is now we are trying to do is to create a fresh water from the sea. But this is not a normal reverse osmosis technology which we all familiar. This is we are trying to mimic the monsoon. So what is done is that the seawater is brought to the vacuum chamber. So at that temperature, it evaporates and then it is collected into the other chamber for which we bring the cool water from the depth of 800 meter, cool it, and you get a fresh water. This is very unique system which has been developed for the Lakshadweep. And there were 3 plants have been working for last 10 years, continuously providing fresh water to them. And now the another 6 islands are also going to get this kind of fresh water for their drinking purposes. And many people said that the cost is going to be very high, but the cost is only 62 paisa per liter, which is much less. We all have spent about 10-12 rupees for a bottle of water today. This is only 62 rupees, absolutely fresh and water, which is now provided to the islands. And now we would like to scale it up this to provide to large cities like Chennai, where we can generate 10 million liters. Currently, we are generating only 100,000 liters. Next. Many minerals, that especially the cobalt is going to be extremely critical, and there is no land resources for cobalt. And so India has been exploring the deep sea, almost 4, 5, 6,000 meter depth. And now the first level estimate of the Central Indian Ocean has been made is about 380 million tons of manganese, cobalt, nickel and copper available there. And 75,000 square kilometer area India has explored. And next, after there are a lot of technologies you can see in the middle. It's called remotely operable vehicle, which can go up to 6,000 meter. It can make photographs, it can collect samples. Whatever payload you put, it can do that work. So this is development of technology to go right up to 6,000 meters is also. So there are many other things have been developed, automatic testing of the strength of the bed, then the mining, and such things are under development. Also the manned submersible is also under development. Next. Similarly, this hydrothermal sulfides is also one of the very important area where you also get gold and silver. So India has started exploring about 10,000 square kilometer area, and you can see some plume coming out. This is what called a hydrothermal plume. And when it comes out also, the certain metals are leached. And this is what is now being explored. I understand that they have located some of these vents and the next level of exploration is going on. Next. Next. No, I think the gas hydrate, previous one you can go. So another major area is what we have is, apart from the oil and gas, what we call as a gas hydrate. It is nothing but the solidified methane gas. At that depth, about 3,000 meters, because of the pressure, it gets solidified. And this, India has a huge resource of a gas hydrate. There are already two major drilling has been done by ONGC, and a lot of new areas have been found. And the possibility is that if we can harness this, we can use them for almost 100 years. The only issue is that we need to build technology to harness them, because it is under high pressure. And when you release the pressure, it will expand up to 170 times. So we have to bring this at the same level. So this technology is under currently development. Next. And the last few examples on the polar science, Himalaya, you know, these glaciers have been retreating, but the most studies which have been being done is done at the snout level. But now we have started studying the entire glaciers, where the measurements are made right from the snout to the origin of the glaciers, and not only the geoscientific data, but also related to atmosphere hydrology also is being made to understand what is likely to happen. Now, this is very important for us because our northwest area is mostly dependent on the snow melt, like Satluj is mostly dependent on the snow melt, and Bakranangal, which provides water to entire northwest, is dependent. So any change which is occurring in that could affect water availability. So we have to be continuously monitor and understand that the changes which are going to happen in future, how it is going to change the snowfall, the changes in the snow cover and the glaciers. Next. Same time, we also need to understand, as I showed in the first slide, the global. So we have now major experiment going on in the Arctic. Now, many people are asking why we should be in the Arctic. The first, we have now set up the atmosphere and the ocean observatories in the Svalbard, and to make various measurements that what is happening there, what kind of changes are occurring into ocean, what kind of changes are occurring into atmosphere. And many of you would be following, you know that the Arctic is now, the temperature has reached almost up to 38 degrees. So large scale changes are occurring, both in the land ice and the sea ice. Next. So why we should be there? The first reason is that there is a connection between North Atlantic and the changes which can occur there can affect the Indian monsoon. Also, when a heavy rainfall in Northwest can also affect the Canadian Arctic. So we have now also set up a station in Canada, and we need to set up also Greenland and also satellite receiving station, because we need to collect the global data through satellite. So that is also very important. So, and apart from this, our work is also, we are contributing to the global science, which is very important for us to understand that how the changes in the Arctic are going to affect us. So this is one major experiment which is going on. Many institutes, research institutes from India have been participating in this. Next. Next. And the Antarctica, which is also have a very strategic importance. See, currently we have two stations in Maitri and Bharathi, and also we have a major satellite receiving station, which you can see. So we collect the data, global data from the Antarctica, and then it comes back to us. So this is very important for us for a variety of reasons, is mainly for the strategic reason. So currently our main aim is to learn about the science, what is happening there, what is happening onto the ice sheets, what is happening to the uh, biology, ecology, the atmosphere there. So this is also providing to the global knowledge, also important for us that how Antarctica is useful to us. So this is the another major area which India has been pursuing. Next. So basically what I'm trying to say that the knowledge about Earth system is very difficult for any single country to generate the knowledge for the entire Earth as a whole. So we are partnering with the many countries to generate the knowledge for the entire globe, how the different Earth system processes are happening and using them into the models for uh, to meet our not only the national needs, but the regional needs as well. And this knowledge which we have been able to generate, we have been providing to various other the BIMSTEC countries, the RIMES, Indian Ocean countries, and many others. So what we are saying that whatever knowledge we have been generating, we are sharing with the our neighbors. So basically, the Earth science is a global science. So we need to build a collaboration for observations, analysis, and providing the services to the human communities. So basically, this is our goal is to build a knowledge-based society to the sustained planet Earth. And as it was mentioned in the morning, that the Vibha and Vigyan Bharati also is very much try to build a knowledge-based society. And I think the earth science has been in the forefront to build the knowledge for the benefit of the society and planet Earth. Thank you very much.
Thank you, sir. Thank you very much for introducing us to the advances made in earth sciences in India and also how relevant it is to attaining self-reliance in our society. As we are running behind the schedule and Dr. Nayak has to leave for some other engagement, I will be taking only one question right now. This question is from Miss Akriti. She is asking, sir, what is your vision on area of ocean science that India will be leading most in the coming decade? Over to you, sir.
No,
So I can repeat. Yes,
yeah.
sir. I am repeating. What is your vision on area of ocean science that India will be leading most in the coming decade?
Yeah, yeah. Okay. No, I think it's a very important question. And actually, the ocean sustains the planet Earth, you know, because of the weather, climate, and also the resources. There are three, four things which is very important for the ocean. And we are now trying to convert that information for the blue economy. The first is the resources, living resources like a fishery. Um, there are tremendous amount of resource which has not been yet explored. So we need to see that how we can make use of those resources as the population is likely to become 9 billion and the land would not be sufficient. So we'll have to look for more and more for the living resource to the ocean. The second is the water itself, as I showed you the example. The water requirement is increasing, and in many countries, even today, you know, the like Middle East gets most of their water from the ocean. Of course, they are using environmentally unfriendly technology of RO, but we have developed the technology, and actually now the effort should be how we can scale it up. How we can generate 10 million liters a day of water, which can sustain a city. So the second is the water. The third is, which is important, some of the very critical minerals like nickel and cobalt, as the electronic industry is going up and up, and these minerals are not available on land as much as required. So we will have to go to the sea. Apart from many these minerals, also some of the rare earths, some of the platinum group of minerals, also the gold, silver. So we would be depending on this very much. And for that, we would have to build a technology right now. Because if you don't build technology and if you depend on somebody else, the benefit will not come to us but somebody else. So we need to invest, and the government of India is already, I understand, that launch a deep ocean mission, and I think a large amount of funds have been allocated to this, realizing that the importance of this. Also, the ocean, we need a lot of other thing which we'll need to do is the science part, because the weather and climate is controlled by the ocean. So we need to make the observation systems, the in situ observation system, as well as the satellite-based system. We need to continuously observe better ocean, and so that we can understand better, and which will have impact on our weather, climate, and the hazards. Many hazards like sea level rise, cyclones, tsunami are actually generating in the ocean. So there are several things which coming decades, we are going to depend more and more on the ocean. So we need to focus our attention on the ocean. Thank you.
Thank you, sir. We have many questions actually. We cannot take all questions here because of the
I
time
can
constraint.
take one more question. I have still 5 minutes. So.
Okay, sir. There is a question from Ms. Geeta Reddy that what are your advices to the young student and researcher aspirants for ocean sciences?
Yeah, I think what is more important for the students is see although this thing which is happening is because of the large investment made in the education system. And as a young, you need to first and most important thing is you need to observe the ocean, because without the observation, you will not able to learn anything. So those who want to pursue the ocean related studies, I think the fundamental thing is the observation of the oceans. This can be done by variety of things, and that means you can see satellite images, you can take whatever data available through the moored platforms, buoys, the drifting buoys, also while taking a ship cruises. This is the most thing. Then what are the questions which we need to answer? Like if you ask me Indian Ocean, the most important question which we are now trying to answer is why Indian Ocean is warming faster than other two oceans, and what are those implications on the us. We have already launched a 10-year major experiment which is called Indian Ocean International Indian Ocean Expedition, where we are trying to answer some of these questions. Already some 40 expeditions already been taken, and many more are in the coming. So you need to participate in some of these expeditions where some of these questions which have been posed are being answered. So this, I think the most important part today is we need to understand the ocean. And because a lot of things are dependent, our monsoon, our hazard, everything comes from there. And unless and until we have understanding of the ocean, many of the questions which we have been facing today, we will not be able to answer. So my suggestion is that you should not only study, but you should get into a research where certain questions are being asked and answers are being found. You should get involved in this kind of an expedition. In India, these efforts are being coordinated by INCOIS, and you can be in touch with the Dr. Srinivasan and the others. So they would be able to provide you more. Actually, there is one very good newsletter coming out. You can subscribe to that newsletter and try to understand what is happening in Indian Ocean.
Thank you, sir. Actually, we cannot take any more questions. So I request audience to communicate with sir. He's very much reachable. You can get his contact details at the at the websites we are sharing at the chat box. So we will be not taking any more questions now. Sir, we are honored to listen to your lecture today and also to have you today. Thank you so much for giving your valuable insights on earth sciences. Sir, I am sure your address is surely going to motivate many of our youngsters to join this field of science. Thank you so much, sir.
Thank you very much. Thank you.
Thank you, sir. I now invite Dr. Anis, the coordinator of IISF from INCOIS, to propose the formal vote of thanks. Dr. Anis, please.
Yeah, thank you, Prerna. So First of all, I would like to thank the organizers of 6th Indian International Science Festival, that is Ministry of Science and Technology, Ministry of Earth Sciences, Ministry of Health and Family Welfare, for giving the opportunity to host this event from INCOIS, and also the Vigyan Bharati, which is also hosting this event along with the INCOIS. There is one more thing to mention here. There is a message from Dr. Rajivan, the Secretary of Ministry of Earth Science, and he has sent his best wishes for the successful conduct of this event. I also thank him for his support and encouragement. I also thank Dr. G. Bhanuprakash Reddy, who is the President of Vigyan Bharati Telangana chapter, along with Sri JLN Murthy and representative of IISF 2020 for helping us to prepare and execute this program of the today's event. I also sincerely thank Dr. T. Srinivasa Kumar, Director of INCOIS, for his support and guidance and also encouragement, along with the co-host of this event, Dr. V.M. Tiwari, Director of NGRI, Dr. Sudip Mazumdar, Director of NIAB, and Dr. G. Padmanabham, Director of ARCI. A very special thank to Dr. Shailesh Naik, Director of NIS, also former Secretary of Ministry of Earth Sciences, and also the former Director of INCOIS, for accepting our invitation and taking time from his busy schedule to deliver a very enlightening and informative lecture on earth science for self-reliant India. And at the end, a very special thank to all my colleagues, Dr. Nimit Kumar, Dr. Prerna Singh, Dr. Kiran Kumar, and Dr. Rohit for making all these arrangements and making possible this event a very big success. Thank you very much.
Thank you, Dr. Anis. Actually, we have now come to the end of today's morning session. I once again thank all the speakers for their time and insightful addresses. Thank you all. We will now move on to the breakout session. Here, all the participating institutes of today's first session are hosting separate outreach programs for students separately on their own online platforms. The links of the same has been shared in the chat box. For example, Vigyan Bharati is organizing experimental video quiz for the students. This ARCI is organizing exciting science lectures webinar. NIAB is organizing scientist meet. Interested audiences may check out these programs at the shared links in the checkout chat box. INCOIS breakdown session will continue here itself, so stay tuned with us for INCOIS outreach session. INCOIS is committed to inculcate the scientific temper among the youth of our country since its foundation for past 2 decades. This organization has opened its door for children and students from various schools. In this session, we will be taking you all with us to a virtual tour of our world in INCOIS. And later on, we will meet few of the young talents of India with their innovative science projects. So stay tuned. I now invite my colleague, Dr. Anis, to guide you all to the virtual tour of INCOIS. Over to Dr. Anis.
Okay, good day, everyone. Those who are connected and watching us live on the YouTube. So, as you know, Indian National Center for Ocean Information Services is a mandate to provide ocean data information and advisory services to society, industry, the government, and the scientific community through sustained ocean observation and constant improvements through systematic and focused research in information management and ocean modeling. So one of our major component is also an outreach where usually we invite the students from the school and also from the undergraduate courses to look at our facilities, what we have and how we generate the products for the societal application. Unfortunately, this year we couldn't arrange a physical tour. So we thought why to be behind and let us use the technology to show the activities of the INCOIS to the audience. So I'll be taking you through a virtual tour of INCOIS. And if you have any questions or any activities, if you want to know specific, you may always write in the chat box.
uphill from the INCOIS circle, on the left-hand side at the end of the road is situated the Indian National Centre for Ocean Information Services. Located in Hyderabad in Pragati Nagar, it is an autonomous body under the Ministry of Earth Sciences. Cut out of forested hills and cradled in the greenery that remained is the main building that houses the operational units of INCOIS. It is mandated to provide ocean information and advisory services to the society through systematic and focused research.
Tsunami is a series of large waves of extremely long wavelength and period, usually generated by undersea or near the coast disturbance. Big tsunami waves can be formed when a sudden displacement of a large volume of water occurs, which happens usually due to undersea earthquake that triggers a sudden rise of the seafloor or submarine or subaerial landslides. The major earthquakes occur in the regions of the earth characterized by tectonic subduction zones, along with the tectonic plate boundaries. Two such regions in the Indian Ocean are Andaman-Sumatra subduction zone, which extends from Himalayan front southward through Myanmar to floors of Indonesia, and the Makran subduction zone, which is located near north of Arabian Sea, comprising southeastern Iran and southwestern Pakistan. Should a tsunami occur in these zones due to major earthquake, the waves in an extreme case will reach the coast within 10 to 20 minutes, causing only very little time left to warn the areas at risk. So a fast and accurate determination of an earthquake parameters like location, magnitude, depth is essential for fast tsunami early warning system. So we have around 400 seismic stations configured here to detect an earthquake occurring anywhere in the world in 8 to 10 minutes. However, not all earthquakes generate a tsunami. So we have to measure sea level changes too. For that, we have tsunami buoys and tide gauge stations. As the sensor network supplies data at only few points, we need simulations in order to synthesize an overall picture of the situation. In this case, we take the help of computer models to ascertain the wave arrival times and wave heights. All available data, information, modeling results finally flow together into a decision support system, which is used in reaching a decision on whether a tsunami warning is to be disseminated or not. On the basis of available information, the responsible person on duty can very quickly get an overview of the situation and generate advisory. If the decision of dissemination is yes, then the bulletins are disseminated to all international, national, and local stakeholders.
Welcome to the Ocean State Forecast Lab of INCOIS. This lab has a state-of-the-art facility that monitors the conditions of the ocean. This information is used by those who are venturing out into the sea, like the fishermen, Indian Navy and Indian Coast Guard, and those at the seashore, like oil and gas exploration agencies, research organizations, etc. We provide forecast of waves, currents, tides, not only for the seas of India, but also for other Indian Ocean rim countries. This information is important for the daily planning of the users, but more so during extreme conditions like cyclones, search and rescue operations in the sea, and oil spills. During cyclones and other extreme situations, based on the forecast information, alerts are issued along with IMD in the form of joint bulletins to the general public as well as the administrators of the coastal stretch under risk, so that the population under threat is relocated to safer places. Prior information on the state of the seas is thus vital for the smooth operational activities in the sea, so that the users can take appropriate informed decisions on the forecast sea state conditions, saving life and property.
The concerted efforts of the scientists from ocean development, space, and fisheries science have culminated into a unique service to provide a short-term forecast, widely known as potential fishing zone advisories, using the remote sensing satellite data. Indian Space Research Organization India has launched a high-resolution ocean color satellite for monitoring of the chlorophyll in the ocean, which is one of the main parameters used in generation of PFZ advisories along with the sea surface temperature. Scientists at the Space Application Center SAC have developed a methodology to integrate sea surface temperature and chlorophyll images to generate the PFZ advisories, and this methodology was transferred to Indian National Center for Ocean Information Services, Hyderabad, for operationalization of the service. And at present, INCOIS is serving about 7 lakhs of fishermen who have directly registered with INCOIS. So India's achievement in this particular field is very unique and was internationally recognized as an operational application of the satellite oceanography.
Welcome to HPLC lab. This instrument is called HPLC, which is abbreviated for High Performance Liquid Chromatography. This machine is used for separation, identification, and quantification of different components in a sample mixture. HPLC is primarily comprised of mobile phase and stationary phase. Mobile phase is the solvent that is used as sample carrier. Stationary phase is the HPLC column filled with adsorbent materials. The other parts are autosampler for programmed injection of samples into the HPLC loop, the photodiode array detector that measures sample absorbance, the degasser that ensures no entrapping of air bubble in the mobile phase. HPLC relies on a pump for pressurized flow of mobile phase containing sample mixture into the stationary phase. In the stationary phase, different components of the sample mixture interacts differently with the adsorbent material, causing different flow rates, which results in separation of the components as they flow out of the column. Subsequently, the components are passed in and the detector generates signal equal to the magnitude of the respective component. The entire process is fully automatic and commanded through the attached computer using specific software. Here at INCOIS, we are using HPLC for characterization of phytoplankton pigments and chromatographic taxonomy. This pigment database will be very useful in understanding phytoplankton ecology, photoadaptation, and defining sensors for autonomous buoy-based and remote sensor-based observations.
Under Ecosystem-Based Fishery Advisory Service initiative of the MFAS program, a project called Modeling of the Primary Productivity has been initiated, under which this lab for the isotope ratio mass spectrometer is being established. So to reach from the chlorophyll image to the productivity-based map, we need to do some experiments on board using the carbon-13 tracer to preserve those samples and analyze them in the mass spectrometer, get two parameters, which is the initial soak and the saturation number called alpha B and PMB. Usually the productivity varies with the light, it increases with the intensity of the light, but it also saturates at a time. So the initial increase is denoted by alpha B and the peak is denoted by the PMB. So we preserve those samples, do the experiment on board, preserve the samples, bring it into the lab and analyze it in the instrument components. First is elemental analyzer, where we put the sample, burn them, produce the gas, carbon dioxide, and bring that lab to the main instrument, which is called the isotope ratio mass spectrometer. Here the carbon isotopes 12 and 13 are getting separated depending upon the mass, and the counts are measured. These counts are then converted into the PI curve, and the two parameters alpha B and PMB are estimated. Now, once we have this alpha B and PMB, then we use a suitable model, these two numbers, and the satellite-derived chlorophyll images to produce productivity map. In future, we will be using this productivity map to give the PFZ advisories. The usefulness of this productivity map is we are one step closer to the actual biomass or the actual amount of organic matter which is available to the fish
and most likely it will give us the better number or the better PFG advisories in the future. Thank you.
This is the satellite data reception facility in INCOIS campus. If you want to receive any real-time satellite data, this kind of facility is required. Technically, we are calling it as a ground station. If you establish any ground station, the range of the ground station is 2,800 kilometers. This is the ocean to data reception and processing facility established in INCOIS with the support of ISRO. This whole technology is ingeniously developed by ISRO, and this is the RF and servo controller. The servo controller helps to focus the antenna and track the satellites, and RF unit helps to receive the sensor recorded information and the conversion of this information into digital form. So this digital data, we are calling it as a level 0 or. So using the raw product, we are deriving the different kinds of products, ocean and atmosphere and land products. If you come to the ocean products, sea surface temperature, chlorophyll and attenuation coefficient. If you come to the atmospheric products, fog product and cloud top temperatures. If you come to the land, vegetation index products we are generating. So whatever we are seeing on the screen is the live satellite data reception. It is covering the Himalayan region. Our ground stations covers this total North Indian Ocean, and this real-time satellite data is available at INCOIS.
So you can see we have disassembled entire glider. This is actually part of the sea glider. We have the bladder. Once the oil will be here, so once it is there at the surface means oil will be full. When it goes down, while it is going down, oil will be sucked from the bladder to the reservoir. These are the different sensors of sea glider. One is the dissolved oxygen. This is the dissolved oxygen measurement under uptowed, and we have FLBB, fluorescence and chlorophyll backscattering measuring equipment. Our PAR, photosynthetically active radiation sensor. This is the PAR. And this is the CT of the glider. This is the conductivity cell and the temperature thermistor. This is sitting on top of the glider, where we have removed right now.
The UCTD is a ship-based system for the measurement of conductivity and temperature profiles while underway. It is capable of profiling to over 400 meters at a ship speed of 10 knots.
Lagrangian floats have been used in oceanography for several decades to make observations of global ocean circulation and water column structure. This float consists of two CTD sensors, one on the top and one on the bottom of the float, measuring temperature and conductivity of seawater. There is an upward-looking current profiler attached to this float called Aquadope, which measures current profiles of top 50 meters. There are two optical sensors in this float that measures the light attenuation with depth. This particular float has an additional buoyancy engine for operating in highly light surface waters of Bay of Bengal. Data from such floats are very useful to study the fine-scale apparition variations associated with the passage of cyclones, mixing and stability analysis, etc.
The VMP250 is a vertical microstructure turbulence profiler for the measurement of dissipation scale turbulence in oceans and lakes up to 1,000 meter depth, developed by Rocklight International. It is equipped with state-of-art microstructure vertical probes, shear probes, high-resolution temperature sensors, thermistors, and a high-accuracy CTD sensor. The azimuth system is a set of 7 very precise sensors that measure how energy and water move between the ocean and atmosphere. Those measurements are the raw materials for many calculations about climatic conditions. Azimuth stands for Air-Sea Interaction Meteorology. The system is used on ships and on buoys anchored in fixed locations in the ocean. The azimuth system provides variables required to calculate air-sea fluxes at the necessary precision using 7 sensors. INCOIS hosts state-of-the-art computational facilities that include a high-performance computer and its allied infrastructure. The network and compute infrastructure are set up in such a manner that no single point of failure can affect the operational services.
Welcome to the data center of INCOIS. The INCOIS website is hosted on the state-of-the-art servers using latest software technologies. The web-based services has always remained one of the core areas of strength of INCOIS. The website services have over the years matured as a prime vehicle for providing ocean data, information and advisory services such as potential fishing zone, ocean state forecast, Indian Argo flows, tsunami early warnings, Indian Ocean, Global Ocean observing systems, etc. The web-based online delivery system facilitates the user with multilingual and WebGIS capabilities to query, analyze, visualize, and download the ocean data information. Development of various web applications and periodical updates of website are being carried out both in terms of information and facilities. INCOIS website being the primary medium to disseminate information of our products is designed using responsive layout, which enables access to a wider range of web browsers and devices, including mobiles and tablets. The website can be accessed at www.incois.gov.in.
I hope you enjoyed the virtual tour of INCOIS. For any details on our working programs, you can anytime write back to us or visit our website www.inquis.gov.in. Please remember, INCOIS door is always open for students and young researchers, and we are very glad to share our achievements and knowledge with them. We will now move to the next segment of this outreach program. As an outreach program for students, INCOIS has organized a science expo competition for school students. I now invite Dr. Nimit to take over this segment and escort us to Science Expo competition. Over to you, Dr. Nimit.
Thank you, Prerna. And this was actually a very unique thing that we are doing, like same in the previous session, that usually we have like around the year a lot of competitions and programs for the students, where students can actually have their own projects that can be displayed, and hundreds of the other students will visit those hosted by INCOIS. Due to COVID, this is all in virtual mode now, but like our director already said, that this did not deter us from conducting the similar kind of session. And we are happy to receive tremendous response, and ranging from all the different class of the students, different standards, and not only from Hyderabad but also from different corners of India. So we will not be able to show each and every entries right now, but we are trying to show some select entries. And the youngest one that comes from the 4th standard right the way up to 10th standard. So that is the range of the students, and then it has been compiled on our INCOIS website as well as on our YouTube channel. So I'll share my screen for your guidance. So first I'll show our INCOIS website. All the entries have been shown in this manner. So you can visit that, you can see each of these entries, and then you can go through these videos at your own convenience. Also, we have created a playlist which I'm going to showcase right now. So that the playlist, it is on our YouTube channel, and I will play all the entries. This playlist also has the virtual tour of INCOIS that is already been covered. So I won't cover that part. So I'll just share the screen along with the audio so that you can, go through the sound as well. Enjoy the show.
Hello everyone, this is Nitik of 9th standard studying in Sangeeta School. I'm here to discuss and explain my project Peer Reveals for Atmanirbhar Bharat contest. My idea is based on the principle of piezoelectric crystal. Piezo is a device which generates electric current when pressure is applied on it. With the help of pressure applied by the wheel on piezo crystal, we generate electricity. This is the structure of wheel in my project. As we can see, the four yellow circles are piezoelectric crystals attached to the rim of the wheel. The blue color tube is a pipe from which the positive and negative wires run. All the wires are brought to the hub of the wheel. Then all the positive wires are connected to another wire, so are soldered to another wire which is connected to a positive terminal of the battery, and all the negative wires are connected to another wire which is soldered to the negative terminal of the battery. When the wheel, now let's know the working of the project. When the wheel of the vehicle rotates, the mechanical stress exerted by the vehicle on crystal is converted into electrical energy using the piezo crystals. Piezoelectric crystals are enabled to produce electricity due to the piezoelectric effect in the vehicles during the course of journey. Using this method of generating electricity for different hybrid cars, energy efficient means of transport can be created. Since in the future there will be only electric cars, this project will be helpful in generating electrical energy, which will not require recharging the battery. Also, it in turn helps in conservation of fossil fuels, which are on the verge of exhaustion. As the contest name suggests, Atmanirbhar Bharat, meaning self-reliant India or self-sufficient India. India can become self-reliant if it concentrates on its future citizens and educating them with alternative but affordable methods of conserving the nature, the life giver. This project helps in conservation of fossil fuels and reduction of air pollution, which in turn preserves fossil fuels for the upcoming generations, and also a pollution-free environment in the future. Makes India self-reliant. Thank you.
My name is Keshav from Sumitra School, studying in 9th grade, here to explain about my project, Bathwater Harvester. Water scarcity is a problem faced by many parts of the world. I researched about a bit and got to know that out of 2 trillion gallons of water being wasted every year, 1.2 trillion gallons of water is being wasted only because of using excess water while bathing. That is when I got the idea of my project. Bathwater Harvester aim is mainly to conserve water and put it to good use, such as watering plants, washing utensils, clothes, etc. Materials used or required to make my project are live straw, tap, pipes, drain, water pumps, 2 containers, and a harvesting pit. To make the harvesting pit, step 1. Take the container and insert a metal sheet as shown in the below figure. It need not be only a metal sheet. It can also be any other material which is strong enough to withstand the weight we are going to put upon it. Now, fill the first 1/4 of the container with coal and the next 1/4 over the coal with silt and the next 1/4 with gravel over the silt, and over the gravel leave the empty space. Now, to build the whole of the bathwater harvester, dig a hole in the bathroom floor and install the drain. Attach the drain to the harvesting pit using PVC pipes, a motor, and a carbon candle filter. Next, connect the first container to the second container through the hole with the help of PVC pipes, mortar, and a live straw. Make a hole at the bottom of the second container and fix the tap from the outside. Now, your bathwater harvester is ready to use. Now for the expenses of the project. Water harvester 500 to 700 rupees per bit. Carbon filter candle 500 rupees. Flexible PVC pipes 45 rupees to 180 rupees per meter based on quality. Bathroom floor drain 500 rupees to 1000 rupees based on size. Installation cost 500 rupees to 600 rupees. Water pump 400 rupees to 600 rupees. Lifestone 1500 rupees. Total approximately the bar water harvester would cost 3945 to 4480. Rounded off cost 4000 to 4500. I conclude that my project will help conserve water by recycling it to be reused. It is also affordable and can be put to effective use. Thank you.
Good morning, one and all watching this video. This is Harshit along with my team, Harshvardhan Singh and Harshvardhan M, here to give you some information about our project and explain about it. So firstly, there are many deaths happening per minute in India due to road crossing. So our idea is to reduce these accidents in a cheap and effective manner. In an hour, there are 53 road accidents happening in India and 17 people die due to this. Haryana tops in number of accidents, but Maharashtra tops in number of deaths. Now my friend Harshvardhan Singh will give a detailed explanation on the project.
Thank you, Harshit. So, basically, our idea is to reduce the road accidents in this manner. These box-like things present at the sides of the road act as barriers to the people trying to cross the road when there's a red light for them. As the traffic halts, the barriers open and the pedestrians can cross the road by using the zebra crossing. Now my friend M. Harshvardhan will continue.
Thank you, Harshvardhan Singh. When the green light is about to appear for the traffic, the barriers close 10 seconds before the green traffic light appears. So when there is an emergency to cross the road, there's a small button that presses the traffic light to red and opens the barriers. We hope that it helps to build the Atmanirbhar Bharat or the self-retaliate India. Thank you.
Hello, my name is Chet Sriram. I'm studying in Samamitra School, Hyderabad. Today we are going to talk about alternative fuel made from algae. Algae is produced on a large scale. Firstly, it must be sent for the oil extraction. Oil is extracted from the algae. Then it must be sent for the factory for the refining. Once the refining is done, it is ready for the public usage. It is important to conserve the precious resources. Air pollution is increasing day by day. The price of the fuels are rising as their supply is reducing. There is an urgent need to find the alternative kinds of fuels that will pollute less and last for long. Benefits of this project are algae grow in a wide range of aquatic environment, from fresh water through saturated saline. Algae efficiently use carbon dioxide and are responsible for more than 40% of global carbon fixation, with majority of production. All algae have the capacity to produce energy-rich fuels. Challenges faced in this project are its construction cost is too high, algae growth may create quality variations in refining process, algae biofuel doesn't always meet its energy targets. Thank you.
Hi everybody, my name is Anishka, studying in 4th grade in the Creek Planet School Ministry campus. Today I'm going to be talking about bridges. Bridges are structures which are built for providing passage over rivers, lakes, railway lines, roads, etc. Making a bridge is a hard and complex process. It needs several skilled and unskilled people. Architects are involved in designing and planning the layout, and engineers are involved in making sure everything goes as planned. Today I'm going to be speaking about cantilever bridges. These Bridges consist of cantilevers which project horizontally into space, and it also consists of a horizontal structure called beam. These bridges are made up of steel and concrete, thus having many pillars for support. The Howrah Bridge over the Hooghly River is in West Bengal, India, is an example of cantilever bridges. The Howrah Bridge daily carries approximately 1 lakh vehicles and 1,50,000 pedestrians, making it one of the busiest bridges in the world. Thank you.
નમસ્કાર, મારું નામ ભાગેલા વ્યોમ છે. હું શ્રી કલા મંદિરમાં અભ્યાસ કરું છું. આજે પ્રયોગમાં પ્લાઝમા પાયરોલિસિસ એની ઉપર ડિસ્કશન છે. તેમાં સમગ્ર લાઈવ આકૃતિ તમારી સ્ક્રીન સમગ્ર રજૂ કરવા જઈ રહ્યો છું, જેમાં આકૃતિની સંપૂર્ણ માહિતી છે. જેમાં સૌપ્રથમ ઘન કચરો એટલે કે પ્લાસ્ટિકના કચરાને હોપર નંબર 1માં દાખલ કરવામાં આવે છે. ત્યારબાદ આ હોપરમાંથી ઘન કચરો ધીમે ધીમે શેડર મારફતે ઉપર તરફ હોપર નંબર 2 તરફ લાવવામાં આવે છે. ત્યાંથી આ ઘન કચરાનું ગ્રાઇન્ડિંગ એટલે કે સૂક્ષ્મ કણોમાં વિભાજન કરવામાં આવે છે. ત્યારબાદ આ ઘન કચરાનું પાયરોલિસિસ થાય.
So here I would take a moment and just tell to the participants or viewers that like I said, we have been receiving these entries from all over the India, and INCOIS gives these advisories and information in all native coastal languages. So when we receive the entries, we had not keep any bar in content of the language where we receive the entries, so that you can see the entries coming from Gujarat and even from Assam that will be exhibited here. So accordingly, the language would be in their regional language. It might be for some entries, but then the content on the visuals that would be in English, so that you won't be facing any problem in understanding what is going on. So this is more about the handling of the solid waste on then doing the plastic and pyrolysis. Next entry would be about automation of the machinery for the self-reliant India. And I hope the language would not be barrier for you either in appreciating these entries.
જેમાં જનરેટર મારફતે ઉર્જા આપી વિદ્યુત ઉર્જા આપીને તેનું પુષ્કળ માત્રામાં દહન કરવામાં આવે છે, તથા આ ચેમ્બરને પ્લાઝ્મા ગેસિફાયર તરીકે પણ ઓળખવામાં આવે છે. ત્યારબાદ આમાંથી વધેલો નકામો કચરો તે નીચે તમે જોઈ રહ્યા છો હોપર છે તેના મારફતે નીચે તરફ આવે છે. ત્યારબાદ આગળના જે કામના વાયુ છે તે આગળ નળી મારફતે શેબરમાં દાખલ કરવામાં આવે છે. આ ચેમ્બરમાં પુષ્કળ પ્રમાણમાં પ્રેશર આપીને તેને ઠારણી ક્રિયા દ્વારા પસાર કરવામાં આવે છે. ત્યારબાદની પછીની હોપરમાં સાયક્લોનમાં દાખલ કરવામાં આવે છે. ચેમ્બરમાં તમે જોઈ શકો છો એકદમ સાયક્લોનની જેમ જ પ્રેશરાઇઝ કરવામાં આવે છે સંપૂર્ણ ગેસને. ત્યારબાદ આ પ્રેશરાઇઝ ગેસ તે બૂસ્ટરમાં દાખલ કરવામાં આવે છે, જે ગેસને ફૂલ પ્રેશરાઇઝ કરીને આગળની ચેમ્બરમાં દાખલ કરવામાં આવે છે. આ સમગ્ર મોટી ચેમ્બર તમે જોઈ રહ્યા છો તે જનરેટર છે, જેને પ્લાઝમા જનરેટર પણ કહી શકાય છે. ત્યારબાદ આમાંથી ઉત્પન્ન થયેલી વીજળીનો પુનઃ રીતે તમે ફરીથી પ્લાઝમા પાયરોલિસિસમાં ઉપયોગ કરી શકો છો. આ છે સમગ્ર માહિતી પ્લાઝ્મા પાયરોલિસિસની.
এইটো হৈছে পাৱাৰ বেছ অট'মেটিক স্পিনিং মেচিন, মানে স্বয়ংক্ৰিয়ভাৱে সুতলোৱা যন্ত্ৰ। আমাৰ আগৰ দিনত যিটো ডাঙৰ যঁতৰ আছিল, সেই যঁতৰটোত পুৰণিকলীয়া যিটো ডাঙৰ যঁতৰ, সেই যঁতৰটোত আমাৰ থবলৈ বহুত ঠাইৰ প্ৰয়োজন হয়, কাৰণ যঁতৰটো বহুত ডাঙৰ। আৰু সেই যঁতৰটো আমি যেতিয়া ববিন লৈ থাকোঁ বা মুহুৰা লৈ থাকোঁ, মুহুৰা লৈ থকাৰ ফলত আমাৰ বহু সময় ধৰি একে ঠাইতে বহি অকল এটাহে ববিন ল'ব পৰা যায়। বহু সময় ধৰি এটা ববিন ল'ব পৰা যায়। আৰু আমাৰ সেই যঁতৰটো চলাব লাগিলে আমি এখন হাতেৰে যঁতৰটো ঘূৰাই থাকিব লাগে আৰু এখন হাতেৰে আমাৰ সূতাডাল ধৰি থাকিব লাগে, যাৰ ফলত আমাৰ অন্য যিবিলাক কাম থাকে সেইবিলাক কাম আমাৰ এৰি থৈ এই যঁতৰটোৰ লগত লাগি থাকিব লাগে যেতিয়ালৈ ববিনটো লোৱা নহয়। তাৰ প্ৰতি লক্ষ্য ৰাখি মই এনেকুৱা এটা যন্ত্ৰ উদ্ভাৱন কৰিছোঁ, যিটো যন্ত্ৰ
So here I would like to again brief something that the entries have been focusing on the various issues, and one of those is the as we are all concerned that India needs to be self-reliant for the fuel. So those kind of entries that you have seen the entries related to public health and safety, and who can forget about the COVID. So after the regional entries, we come back to some entries from Hyderabad again, and especially focused for the COVID related solutions. So enjoy those entries.
Welcome to one and all. This is Ashrita Kutta of 9th studying in Sister Nivedita School. So today I'm here to present my idea for the Science Expo Competition 2020. My project is to develop a portable protective UVC chamber. So now, what's this? Before getting into this, let us look at our daily lives. Nowadays, everyone is points. So this machine can be used for the sanitization of notes, and therefore even the bank employers can feel a little safe by using this. So now let me explain you about this. This type of machines can be seen in railway stations, metro stations, etc. for security purposes. But here we have a UVC light fixed here. So a curtain or a plastic sheet should be around that so that the UV rays doesn't come out. So this is a belt-like thing. So when we place a note or a baggage on this, it just passes from under the UVC light and thus they get disinfected. So there's a mini box can be used in banks for the disinfection of notes, and a larger size of this can be used for baggage disinfection. Not only during this COVID-19, even it can kill viruses and bacterium of any kind. It has a power, the UVC has a power to eliminate any type of virus or bacterium. It destructs and destroys the DNA of a microbe. Thus, it can be used during any such outbreaks in future. So I hope you are clear with my idea. Thank you.
Good day all. The title of my project is Personal Protective Equipment, PPE and Medical Waste into Bioliquid Fuel. Countless face masks have been littering the streets following the COVID-19 pandemic. Medical wastes and medical grade masks are commonly made from polypropylene, a very dense thermoplastic. To prevent the masks from becoming a significant threat to the environment, we have to recycle the masks into something more valuable, something which is essential for human life, like fuel. So today I have made a prototype model for my project, which is making bioliquid fuel out of polypropylene. After burning of single-use PPE, that is personal protective equipment items, the chemical process breaks down the mixed plastics at a high temperature between 300 to 400 degrees centigrade for an hour without oxygen. Generally, this process is called as pyrolysis. Doing this facilitates thermal cracking of macromolecules. After the process of pyrolysis, we can observe that the liquid fuel is flowing in the tube. The challenges of PPE waste management and increasing energy demand could be addressed simultaneously by the production of liquid fuel from PPE kits and medical wastes. The motto of my project is Clean India, Healthy India, and Energetic India. Done by Jaswant Srinivasan. Thank you.
With this, we come to an end of this session. And as I have shown earlier, either on the INCOIS website with all the details or on the INCOIS YouTube channel, you can go through these videos to go one by one. And why we have created both is that here you have the compilation of all the entries, and you can see that those themes range from the fuel efficiency to COVID and making India self-reliant in that context. And here we have created the playlist with each video uploaded separately, because then you can like or share those projects to others whom they might be feeling interesting, and then they might want to have questions for those students. Maybe students can have their own networking to each other. So we wanted to have the IISF and this event as a platform to bring together all the students. And I again apologize that we could not include all the entries due to the shortage of time, but all the efforts were equally appreciable and ranging these like wide themes. And everybody who has participated will get certificates and all the logistics and other things. For that, I would request my colleague Prerna to go for the final announcements. So hand it over to you, Prerna.
Prerna, you are muted. Unmute yourself, please.
Okay, sorry, sir. Thank you, Dr. Nimit. Indeed, they were some of the very good science projects from the students, and this is what makes us proud of them. Actually, we have now come to the end of this event. On behalf of INCOIS, I once again extend my heartfelt thanks to all who have joined us today. I hope you all enjoyed the event and must have gained some scientific outlook from the talks of our esteemed scientists. Thank you all for the participating in today's program. We hope to see you again next time. Do subscribe to our official INCOIS channel on YouTube to get the intimations of future webinars from INCOIS. Thank you all. Stay safe and goodbye. Jai Hind.